Hi everyone, my name is Gary Bartanian, and I'm a UCLA student and a stats major. And me and my partner Robin are going to be talking about the 5 assumptions of linear regression. First off, as he listed the 5 above, I want to dig deep within each and give a great example. With the first list that he brought up is that each one should have no to little multicollinearity. In real life, you want to get rid of that as much as possible, but sometimes you do end up with it. But you also need to realize that should multicollinearity be found, it does violate one of the 5 assumptions. So please keep that in mind when you're doing research. And instead of talking more about theory and more about abstract concepts, we're going to be going into concrete, detailed, and examples for the other 4 assumptions. Looking to my left, we can see 4 different graphs of normality. You are getting the standardized residual, and you are plotting it on theoretical quantiles. Before you do that, you must sort it and make sure that it follows the routine. Ideally, we're going to start with the first one. You see how it curves over here? Using the QQ plot, you ideally want it to be on this linear route, and because you have this giant divergence towards the end, you do not think that this is a good representation. Furthermore, looking at the examples over here, where it kind of just like converges out over here, and does not follow the linear path. Looking at these in RStudio or any other statistical software, these violate the assumptions of normality. However, if you look at this graph over here, you can see all the points being on the line and fulfilling the assumption of normality. In real life, you might not have a plot this perfect, but the nearer you are to it, the better, the more you fail to reject the assumption of normality. And we shall move on to the next slide. Homoscedasticity. Robin talked a little bit about this, and I'm going to be showing examples. For homoscedastic, you'd like all of them to be scattered around 0, like this. Make sure there's no concentration in small areas. Like for example over here, this part's fine because you have a nice little distribution, and you have a nice little distribution over here, but you have a huge concentration in this little area. As a result, I'd be very suspicious, and in good faith, I cannot say the assumption of homoscedasticity is being met. Likewise over here, this part is fine, but over here, you have a small cluster. Furthermore, it's also nice to note that this part diverges towards as you get further increased. That can't happen, and that does not allow for homoscedasticity to be appeased. And then lastly, in this direction, you have this weird zigzag, and ideally you'd like it to be scattered across 0 and looking like this. Thirdly, we have the standardized residuals versus the fitted model. In this case, we'd also like to see points being scattered around as Robin is zooming in. I'd like to get your attention to the bottom one. So the bottom one is the ith standard residual to the I-1 standard residual. This shows that if there is a relationship between the first one and the previous number, so an ACF or autocorrelation function of 1, ideally you do not want this, because if there's a correlation between the ith number and I-1 number, there is no independence, and this entire figure, or this entire assumption model that we're trying to prove is that there is assumption of independence. In this case, there is no independence because you can see that there's somewhat of a relationship between the I and I-1, while here it's all pretty much scattered around, and you have a random not completely random, but you have a somewhat random graph, which means that you can not fail. You fail to reject the independence. Lastly, take us to our last graph. The last one is the standardized residuals versus covariance, and it is the assumptions of linearity. Again, you'd like your points to be scattered around 0. In this case, you're getting way too much change, you're getting way too much curvature and divergence. You cannot accept this graph. Same with this one. Having these curves are not good indicator. This one is a much better one, but I'd still feel extremely cautious to get the assumption of linearity looking at this model because of this part, and towards the end where it slightly converges towards downside, and this part. Ideally, and again, ideally you'd want something like this where it's near flat and you have points scattered around 0. And on that note, thank you so much for tuning in and hearing about the 5 conditions of linear regression. Thank you so much.